exploring a fascinating paper that tackles the increasingly important problem of distinguishing between code generated by large language models, LLMs, and code written by humans. The authors propose a novel method, CodeGPTSensor, to address this challenge. What's the core issue this paper addresses, and why is it so relevant?
The core issue is the difficulty of reliably identifying code generated by LLMs like ChatGPT. This is crucial because LLM-generated code can have quality issues, security vulnerabilities, and ethical implications related to plagiarism. Being able to distinguish between human-written and AI-generated code is vital for maintaining code quality, ensuring software security, and upholding academic integrity.
So how does the current landscape of AI-generated content detection look in relation to code? Are existing tools up to the task?
Existing AI content detectors are primarily designed for natural language text, not code. The paper shows that these tools often fail to accurately distinguish between human-written and LLM-generated code. They struggle to capture the subtle differences that might exist.
That's interesting. What makes distinguishing LLM-generated code so challenging? Is it just a matter of the LLMs getting better?
It's not just about LLMs improving. Human-written and AI-generated code can be semantically very similar, performing the same function. The differences often lie in subtle aspects of coding style, structure, and the way the code is organized. These nuances are hard for traditional methods to pick up.
The paper introduces CodeGPTSensor. Can you explain the approach they take?
CodeGPTSensor uses a contrastive learning framework. This means it learns to distinguish between human-written and AI-generated code by focusing on the differences in their representations. It uses a pre-trained model, UniXcoder, which is good at understanding code semantics and syntax, and fine-tunes it using contrastive learning to better separate the two types of code.
Contrastive learning. Can you elaborate on that concept for our listeners?
Imagine you have pairs of similar images. Contrastive learning aims to create embeddings, numerical representations, where similar images are close together and dissimilar images are far apart in a multi-dimensional space. The CodeGPTSensor applies this idea to code, pushing apart the embeddings of human-written and AI-generated code.
The paper mentions a large dataset, HMCorp. What's its significance?
HMCorp is a crucial part of the research. It's a massive dataset containing hundreds of thousands of pairs of human-written and ChatGPT-generated code snippets in Python and Java. This large, carefully curated dataset is essential for training and evaluating CodeGPTSensor effectively.
How did they create this dataset? It sounds like a significant undertaking.
They started with the CodeSearch.net dataset, which contains code and doc strings from GitHub. They then used ChatGPT to generate kind based on the doc strings, creating pairs of human-written and AI-generated code for the same functionality. This process involved significant data cleaning and filtering to ensure data quality.
The paper also includes a human study. What did that reveal?
The human study showed that even experienced developers struggle to reliably distinguish between human-written and AI-generated code without the aid of a tool like CodeGPTSensor. Their judgments often relied on intuition and subjective assessments of coding style.
So the human element isn't enough. What about the quantitative analysis of the code characteristics? What did that show?
The quantitative analysis revealed some interesting differences. LLM-generated code tended to be simpler, with shorter functions and less complex structures. It also used more verbose function names and had a smaller vocabulary than human-written code.
Given all this, how does CodeGPTSensor perform compared to existing methods?
CodeGPTSensor significantly outperforms all the baselines tested, including commercial detectors and other state-of-the-art methods. It achieves very high accuracy, precision, and recall in distinguishing between human-written and AI-generated code.
The paper explores several variations and comparisons. What were some of the key findings from those experiments?
They compared different code encoding models, like CodeBERT and UniXcoder, finding that UniXcoder worked best for CodeGPTSensor. They also showed that the contrastive learning component significantly improved the model's performance. Finally, they tested the model's robustness by removing code comments and found that CodeGPTSensor remained highly accurate.
What about the impact of code quality, specifically whether the code compiles?
They found that CodeGPTSensor's performance wasn't significantly affected by whether the code compiled successfully. This suggests that the model is identifying more fundamental differences between human and AI-generated code, rather than just relying on superficial factors like compilability.
This is a really interesting and important piece of research. It highlights the need for specialized tools to address the challenges posed by LLM-generated code. Thank you for this discussion.